My name's John Wetherill. Actually, my career wasn't evangelism as much as it was development. I did some stints of evangelism, but I'm more immersed in the development space. As Mark said, I was at Sun Next, a bunch of startups in the energy space. And just as a little bit of background, the most recent startup I was at, I was responsible for building out a big data acquisition system for smart meters. We built these tiny little meters that very low cost, and I was building out the data system for that. And unfortunately, it didn't succeed. But right after that, I discovered platform as a service, PaaS, in the form of Staccato by Activestate. And the discovery I almost fell off my chair when I saw this thing and realized how many months of my life or years I could have saved if I had had access to PaaS at Sun and at all these other startups. Because it did all these things that I was spending all this time doing. So I called up Activestate, I asked if they had any development jobs available. They said, no, but we have this developer evangelist job, you want it? I said, sure. So I joined 3 years ago. I thoroughly immersed myself in PaaS and cloud and containerization and continuous delivery and microservices. And then as Bill and Martin both mentioned, Activestate was, as of like last week, acquired by HP. So we went from 40 people or so to, I think, 330,000 people. It's quite an interesting transition, to say the least. But I've been there before, and I'm getting used to it. I was at a startup that got acquired by Sun, and then Sun got acquired by Oracle, and now Activestate by HP. And HP then is now moving over to splitting in half, and I'm going to be in the HP Enterprise division. So anyway, that's a little bit of background about me. I always like to, I was told when I first started presenting I should open a talk with a joke, and I don't really know any jokes, but I do know something slightly funny. So, you know these as-a-service acronyms you see all over the place? There's database as a service, and software as a service, platform as a service, backups as a service, DB as a service, all this stuff. What is the funniest as-a-service acronym, do you think? The one I like the most is human resources as a service. And the reason for that is if you pronounce it out, it says exactly what HR is not supposed to do to you. So I've always liked that. At any rate, that concludes the humor section of my talk. So I'm going to be talking a lot about microservices, and just a little bit of background. Microservices, as everybody's heard, it's a big revolution these days. Everybody's keen on it, interested in jumping on board with it. I want to preface this talk with the statement that microservices is a solution to a scaling problem, not a business problem. What I mean by that is if you have something you need to solve, or a problem you want to solve, or an app you want to build, or a service you want to provide, you don't need microservices to do it usually. But once you need to scale this thing, and that means scale it as far as number of users, or number of developers, or size of your system, this is where microservices starts to become very powerful. And you'll see that over the course of this talk. So just some of the things I'm going to cover is just, I've been doing talks on this for a year or so now, and it's getting more and more familiar, so I'm going to gloss over some of it at the beginning. We'll cover a little bit about monoliths, the old way of doing things. Then we'll dive a little bit into microservices, what they are, and some of the benefits. Some of the challenges and pitfalls that people adopting microservices are hitting. And then it gets a little bit more interesting. Some of the practices that are helpful to follow if you are considering moving to microservices, or if you're doing it yourself. And we'll talk a little bit about deployment and DevOps and how all that fits and how you need to tailor your organization to support that. And then we'll dive into some patterns, some actual software patterns, design patterns that are kind of crucial for microservices. And that alone, that second last bullet, could easily be the full hour talk. So I condensed it quite a bit. I just called out a few highlights. And then finally, platform as a service. As I said, I got really meshed with PaaS in the last 3 years. And it's a really great way to move into microservices, and I'll illustrate that towards the end of the talk. So, monoliths. So that's the old way of building applications. That's how we've been doing it for decades now. Monoliths meaning you have this big, massive application, or maybe components of your application, like the front end tier, and the middle tier, and the back end tier, whatever, the database tier. But they're really big, cumbersome, complex things. And it's a convenient way to build out an application, but it definitely has some drawbacks. So with a monolithic application, the complexity of your app is all internal to the app. There's a lot of complexity, of course. Applications are complex. But everything's internal. You have this big object hierarchy and ways of intercommunicating between your objects and back end of your database. But you have these massively huge coordinating systems. And therefore you have these huge teams generally to support them. So it's very common to see that, a large UI team and a large middle tier team and a large back end team, and they're all working together. And it could be, for a large project, it could be dozens or even hundreds of people coordinating on this thing. And it's oftentimes you'll see the whole thing gets packaged as a single WAR file or a single artifact. And so what that means is it can be painful to deploy this thing. It can be very painful to make a change. Even a simple change, you need to rebuild this massive thing and deploy it out to your production. And it's very common that if you need to make a simple change to your application, it ends up taking weeks or months. You end up having to get VP approval in order to get this thing out the door. And it just takes a lot of time. A lot of service tickets have to be submitted, a ton of testing and validation. And it's just a very long stretch, a long path to get from a simple code change to actually seeing it out on the site. And I'm talking about these massive apps that you see out on these big web companies like eBay or whatever, Twitter, Netflix. And I want to mention Netflix specifically. They've been really pioneering in the microservices space. So as I mentioned, I was responsible for building a large data acquisition system. It turned out that we built it using microservices before I'd even heard the word microservices, but it was a very microservices-oriented architecture. And then about a year and a half ago, I went to a talk I think it was at Cisco, and Adrian Cockcroft was there. He was the chief architect at Netflix, and he was the one that was responsible for moving Netflix from their old business of CD delivery to streaming. And he just revamped the entire organization, and a big part of his re-architecture was organizing it around microservices. So I saw this talk by him, and all these light bulbs went off in my head. And I realized that all these things that I've been struggling with or working with or designing over these years, it just follows just about everything he said. So right after that talk, I immediately jumped on board this whole thing. So what he pointed out is the same thing with Netflix. They have this big, huge WAR file. They need VP approval to get it deployed if they need to make a change, and tons of people involved, in months or weeks anyways, to make a significant change. Very cumbersome. The other thing I will mention, though, that is if you are building a new application or trying something out, you probably don't want to start off with microservices because there's a lot of extra complexity and infrastructure and organizational changes you need to make to get this thing out the door. So generally, if you're just putting out your app for the first time, you need to get your customers' eyes on it, it's fine to build a monolith. It just works really well. It's actually preferred to do that because as you're doing that, the requirements are going to evolve and solidify, and eventually they'll solidify, and then you can consider migrating to a microservices architecture. That's the approach commonly used today. Maybe in the future, it'll be more natural to move directly to microservices. Excuse me. But that's the kind of the common pattern now. So, microservices. And I do want to call out again Adrian Cockcroft. So he defines microservices like this: loosely coupled service-oriented architecture with bounded context. And I'm not going to get too much into the definition now, but I'm going to refer to this throughout the talk. Yeah, I'll call that out now and then you'll see how that all fits in. So basically with the microservices approach, you're taking an application and you're splitting it into these small, isolated, disparate components that intercommunicate over the network. So instead of intercommunicating inside a single memory space or application or VM or whatever, they're intercommunicating across the network. And first of all, what that allows you to do is split up each service, each component of your application, so a single team is responsible for that single service. I was going to say something, but anyway, the single team is responsible for that service, and it's responsible for the entire deployment and delivery of that service. It's not like there's a deployment team and a QA team and a development team and a UI team, all this other stuff. There's a single small team that builds out this service, and then they make it available to other teams who have their services or their consumers, basically. One thing this enables is to use the appropriate technology for the task you're trying to solve. So in the old days, it's like, a company says, well, we're a Java shop. You can use Java, you can use Spring, and you can use Oracle, and that's your choice. You can do whatever you want as long as you use those three things. And with microservices, or at least in the modern day, it might make more sense to solve a problem using Node.js and MongoDB, for example. Or anyway, Python and whatever, it doesn't, and CouchDB, it doesn't matter. There's a vast array of technologies that are available. And sometimes it might make more sense to solve a problem with a different technology stack. And then another consideration is that you might, let's say, bring on a new team of people through an acquisition like we just went through. And that team might be specialists in Ruby, for example. And I don't know if you've ever made the transition from Ruby to Java, or at least if you've observed it or witnessed it, but it tends to be accompanied by a lot of grumbling and resistance. And then people that have been Ruby experts all their career suddenly are trying to struggle with Java, and they might end up just quitting, right? Wouldn't it be better to just take that team and focus them on a small component of the app and have them, these experts, build it in Ruby? So that's one thing that microservices allows you to do. You're separating your application into these components, and the technology can match whatever makes sense. And alluding to what I said earlier, it allows you to independently update these components. So you don't have to redeploy the entire WAR file in one go. Instead, you can just redeploy this tiny component that's part of the whole system in one go. And that has a lot of implications for the way your teams work and for productivity and for employee satisfaction and for a lot of things, reliability. It basically empowers the developer. As a developer, I feel a lot more empowered if, when I make a change, I can push it out and it ends up in production that minute, right? As opposed to pushing out a change and then it goes through QA and all these other deployment teams and maybe VP approval and all this other stuff, and maybe a week later this change will end up in production. I feel, and with a lot of IT barriers in the way, so to speak. So I feel a lot more empowered as a developer if I have the power to make a change and then click reload on my browser and see the change immediately. But with that power comes a lot of responsibility. So that also means the developer is much more likely to be very careful and methodical about making changes, because it's going out to production right now. Obviously that enables a rapid delivery cycle. If you can push something out in minutes instead of months, there you go. And and force a strong design, I just said that, is by empowering the developers. So those are some of the benefits of microservices. Of course, there are challenges as well. So enterprise applications are complex. You just can't get around that. And in the old monolithic way, you might have all that complexity built into your libraries and into your application code itself. With microservices, you're distributing that across your network or multiple networks. So it actually increases the complexity, because instead of having this single contained thing without as many network interactions, you're distributing it across the data center or across the world. Another challenge that is inherent with microservices is visualizing what your system looks like. So instead of having these nice compact UML or relatively large UML diagrams describing the flow and everything, you end up having all these separate services and then interconnections between them. And if you've seen some of the diagrams that represent microservices-based systems, it's almost completely impossible to understand what's going on. You might have 200 microservices with connections between all of them. It basically just looks like this big wall of ink. Very difficult to understand or visualize. And microservices are relatively new, at least in their kind of current state. And they're evolving really quickly, and therefore the tool sets to properly deal with them are evolving a little bit behind, and they're a little bit immature yet. We'll talk a little bit about some of those later on in this presentation. There's culture shock in the organization, moving from their old familiar monolithic approach to suddenly this new thing. Might be a lot of resistance. Maybe less experience building a microservices-based architecture as opposed to the old monolithic approach. They say it's much more difficult to change your org chart than it is to change your architecture. We'll get into that. Yes?
It seems like the primary difference really between going, say, back in time, from microservices back to, say, multi-threaded to multi-process, all the way back to a single process. The primary difference is the modules are the same, right? The modularity is driven by the problem you're trying to solve. The primary difference is the communication between them, right? In microservices, I'm using REST interfaces with, say, JSON, for example. Well, in an earlier era, I had a multiple process thing in Unix world. I could have a pipe between them. It could be different languages, and I could have used JSON back then if it existed. And it just seems like the real change here is the communication medium between the modules, not my ability to modularize.
I agree. So just to repeat the question, so how is this any different from the past, where I can take a big enterprise or big application and modularize it just as well, not even with pipes and separate processes. I can even do it within my same memory state. If I very carefully architected it that way. But so you're right. There's a lot of similarities, but some of the ways that it departs are on the deployment model itself. In the old days, it's very difficult to deploy just one thing without having impact all over the rest of the system, and you have to be extremely disciplined not to have any leaks between this and that. And it basically just doesn't happen. It was the nirvana, right, for a long time, but it never really happened. It's almost impossible. Whereas if you have separate teams, then they might be separated by 5 time zones, and they define their interface, and that's all they do.
Right, but I think the traditional solution to the separate teams and to parallelize the bigger problems into smaller sub-problems was to define the interfaces and enforce them, hand the specs to the different teams. They could be anywhere on Earth, and just you follow the spec. Whether you're within the same process or talking via a pipe, talking via a REST interface, there's still an interface, right?
Right, so you're saying, let's say when it's deployed within the same memory space, it's talking REST instead of just inter-object communication kind of thing, or?
Well, I think if it's a single process, then the modules, which are, say, functions and procedures, are communicating via an ABI, the application binary interface, which is enforced by the compiler. You're kind of then really forced into using the same language everywhere, right? Because the compiler needs to see all the modules. If it's a pipe, you're doing pipes are shared memory, in the Unix world. They can be different languages, and they do require a fixed interface. But that's, in my opinion, is similar to the same kind of thing as a REST interface.
I would agree, yeah. You've got the pipe, you're talking some sort of protocol across 2 endpoints, and you could easily implement that with REST.
And the fact that those 2 modules are running on the same machine or different machines, the pipe could be a socket, you don't know.
Yeah, I agree, and that's actually true, because actually microservices has just become a buzzword in the last few years, but it's been really around since the 70s, and Unix pipes are a really good example of the same kind of architecture. But right now it's just coming into vogue with the enterprise developers that are seeing that their old monolithic systems, which weren't following what you're talking about as well. There's a lot of leakage.
One big difference is that if I have a REST interface, I can make that public on the internet or intranet, right? And anybody not just some person that I happen to know who's on my team. Anybody can access it, right?
Yeah, exactly. And then what that allows you to do is outsource it completely. And you just hire some random company to just build that one point and you call out over the network. And that happens very commonly too. I'm going to be careful about answering too many questions, but
just two quick questions, very quick, very short. Are there any automation tools which can automate the whole migration process from monolithic system to fully microservice-oriented system?
Okay, first question is, are there tools to automate the migration?
The
I'll
whole
address that
process.
later for sure. That's a
Okay,
big,
okay.
that's way too much.
Okay. The other question is, are there any sort of scheduling and resource management and resource allocation mechanism right now in modern microservice-oriented system?
Yes, so scheduling managers and things like that, orchestration systems, absolutely, and I'm going to be covering that with you. You have a question? Did you want to?
Well, I agree with Bruce, because that's what your placard says. I'm concerned, I'm not naysaying, I'm just concerned at what seems like a jump from, hey, these teams can work separately to, hey, they should, and what the hell, you know, the interfaces are defined. What my big thing is requirements, and you still got to have somebody managing this whole set. Stuff's gonna get broken, and it's bad enough now with teams, I don't care what the hell your technology is, working independently without any sort of coordination, and I think you just have to be careful when you, I know you don't mean this, but you said, you know, without having to go through QA and all this other stuff, you can just deploy. Oh my God, that's fine if it's an app to find your local dog park, but if it's a spacecraft monitoring system, then no. That's not going to happen. So there's not that much magic going on here. I agree. There's something in this technical implementation side that maybe is beneficial, but you can't just get rid of all this overarching organization and quality control and coordination of requirements.
Fully agree. So yeah, and I misspoke if I did say, I think I did, about you don't have to worry about QA. But what you're doing is you're taking your individual component and baking the QA into that much more directly, so you're really testing that component, that service itself, every possible thing, or everything you can consider that would fail. You're covering that, and then as you'll see shortly, we'll talk about versioning and be able to version forward and back these services and retaining the previous versions and things. There's a lot of techniques that are being followed that solve those exact problems. So yeah, we'll get into those shortly. So great questions. I just want to be sensitive of time, and I'm going to cover most of this in more detail shortly. So actually just, good timing here. So some of the practices that are commonly being followed by enterprise, and by the way, so as I said, I built a microservices system. I saw Adrian Cockcroft's talk, and then I've been talking to dozens, hundreds of developers, that's part of my job, about what they're doing with microservices. So what this presentation is kind of a distillation of many of the things that I've learned. The things that I think are important. So there's this practice called immutable code service patterns, where when you deploy a new version of a microservice, let's say, of a service, you keep the previous one active and in memory and running at all times while this new one is out there running. And what that allows you to do is you deploy the new version, and you can gradually adopt it from the consumers, so the consumers can gradually start using the new service, and that way you can do things like roll it out gradually or do A/B testing, all these other things. But the point is that once there's a failure or there's a problem, you can instantly roll it back, so all the consumers will actually get access to the previous service. And there's a lot of tools and practices and patterns that enable that.
So do the service consumers get a say in whether they use the new or the old one?
Yes or no, it depends. That's sort of an implementation detail. Do the consumers get to say which one they use? And that depends on how you want to build this out. And it depends. There's so many ways to do this. Either the consumers decide. There's actually libraries. There's tools out. Netflix has produced this thing called Eureka, which enables that a lot. It's client-side service discovery stuff where. And basically client-side load balancing, where the consumer does get to choose, but you don't have to follow that pattern.
So how do you determine a reasonable or suitable granularity for your microservice?
I'm sorry, I didn't hear the question.
How do you determine the microservice's granularity?
Right, okay, that's a great question, thank you. How do you determine the granularity of your microservice? In other words, how do you split it up? How do you know whether to go?
It can be very coarse, very fine.
Very coarse, very fine. If it's very coarse, it's a monolith.
Yeah,
If it's
I
very
mean, yeah.
fine, you're taking a single method or something and wrapping it up as a microservice. So, and that's where I wanted to go back to Adrian's quote here. That's it. It's basically like service-oriented architecture has been for years, but that had a problem with your question exactly. And the answer to that is partition it based on your domain problems, your specific things you're trying to solve.
Case by case. You use case oriented.
Yeah, exactly. Depends.
So actually, the other side is called how loose it is. How loose can it be?
Right, and that's up to you. That's up there.
Yeah.
And again, it's evolving a lot, but that's exactly the things that people are trying to figure out, like how granular to make this thing, so that you get all the advantages without all this incredible overhead, like a team for a method, right? Which is pretty ridiculous. So that's exactly some of the challenges that that we're coming up against. So I'm going to move down quickly. Another common practice that Netflix has kind of pioneered or whatever, or brought into the mainstream, is deliberately breaking things. So as you're building this thing out, you want to, from the very beginning, make sure that you break these microservices, break these individual components, so that the other components can gracefully deal with failure. And Netflix has built this tool called Chaos Monkey, which breaks your system in various ways. It does all sorts of weird things, like randomly introduce timeouts when you call a method, or random data coming back, or just doesn't respond, or exceptions, or whatever. You want to be able to do this deliberately, so then your system can adapt to it and recover from it, as opposed to learning about it while it's out in production at 3 in the morning when you do not want to learn about it. Very important, no manual anything, no human intervention anywhere. I've talked to several, I talked to all these big companies like banks and insurance that are going towards this microservices thing, but they're so entrenched in their old ways, right? So yeah, we're doing all this microservices, it's really quick, but you have to submit a service desk ticket to get a VM spun up. And guess what? It takes 3 months to get your VM. And that's actually kind of a lower edge. And I actually talked to a company a few weeks ago that said it's 9 months for a developer to get a VM spun up. And I almost can't comprehend that. But the point is, that's just not going to work. So in order to successfully move here, you need to be able to provision whatever components are needed, not in a month, not in 9 months, that's for sure, more like in 5 minutes, if possible, or even less. 1 minute if possible. So that's where it needs to go to make this successful. Another thing I'll talk about, a very common or very important thing to do is, so microservices, I didn't talk about a lot, but they communicate with each other over the network. The common way to do this is over REST, is JSON over REST, but it doesn't have to be. It could be SOAP if you really want to use it yourself, or it could be anything, any messaging systems, or it doesn't matter. However these communicate, it should be the job of the creator of the microservice, of the service itself, to provide access libraries, because if you don't, then every consumer that needs to consume your service is going to end up writing their own libraries, because they need to wrap common calls, right? Because there's low-grain calls to do whatever it is you're doing in your microservice. And they're obviously going to want to, maybe wrap an authentication with a GET, with a POST, and all this other stuff that you're doing to create something and read it first and create a new one, whatever. You get the idea. Provide libraries to do these common things, and that way, first of all, you own them. It becomes a reference implementation of the calls to your service. So now you have a reference implementation, and then it also allows you to do other very important things like deal with timeouts properly, which we'll get to, and other stuff. So creating and curating access libraries just means providing libraries for your consumers to call, so they're not necessarily directly calling your APIs directly. Yes?
Does that go in the opposite direction from allowing everyone to use their own language? Because it seems like I would have to provide access libraries in whatever languages the consumers might be using.
Right. So how does this line up with this polyglot idea where you can use any ideas, any languages. And that's a good point, but so the libraries I've seen have been sometimes even like shell wrappers, so it's basically bash, which you can invoke from any language, right? Or other things that are invocable.
You could use camel.
Camel, Apache Camel. I love Camel, man. That's a great, yeah, that would work really well. Yeah, so there are ways around that, but you're right. But then, okay, later on I'm going to talk about the benefits of polyglot versus monoglot. Like, do you really want to have multiple languages in your organization or not? There's pros and cons, we'll get to that shortly. And I'm a little bit concerned about time here. About half an hour, okay. DevOps culture is a must. So this whole DevOps thing, basically instead of this big monolithic organization, right, that's dealing with all your ops and all your infrastructure and everything, databases and all that, you need to reorganize your entire company properly to deal with this. That's a big stretch and it's not going to happen, but at least you need to start off with reorganizing parts of your company. So instead of this IT department and dev kind of at odds with each other, you actually have everybody part of the same team. So ops, devs, QA, deployment, all the components of this thing are all part of the same team, a small, close-knit team. Now, the old way, and I've been there many times, and it's dangerous. I would say it's absolutely dangerous, or at least it's really destructive. As a developer, I submit a ticket, and then I wait 2 weeks, and say, what's going on? What are these guys doing? And it turns out that they're, because they're swamped, they're prioritizing what they do. But it ends up creating this discord between the two divisions. And I've seen this so many places. And any place where you have this, toxic relationship between two teams, it can only be bad, right? Imagine how much different it would be if they're all basically in the same meeting, stand-up meeting every morning, and they're all working together, and it's a totally different world. So.
On your last slide, you had something called avoid the trunk problem.
Oh, I'm sorry, did I miss that? Yeah.
Trunk conflict, what was that?
What I mean there is, and it's common to build out microservices, but then you check everything into a single repo in Git or whatever, and don't do that. The idea is that you want to have a separate repo, because if they're all tied together, you're not going to be able to evolve each separately. It just gets really complex. So that's what that meant. And I apologize for skipping.
So what is the active status microservice approach, or HP's microservice?
Right. Oh, that's a good question. What is HP?
Make it very short if you answer.
Yeah. I actually just started with HP, and I'm trying to figure out this.
Active status.
But Activestate, we really into this microservices thing, and that is we built our platform as a service to support all this stuff I'm showing you, and I'm going to make sure I have time to cover that at the end. Important thing. So I said eliminate all manual intervention. Also eliminate any process as much as you can to get things out the door, and make operations should be an API call, not a service desk ticket. So it's not like you shouldn't have to click and type and wait. Instead, you make it an API call, and you can call from a shell script or from a Python program or a Java HTTP client, it doesn't matter, to spin up a VM or get a database instance or whatever else I need to do. I'm just saying this 2-pizza team rule, that's Jeff Bezos from Amazon, he's got this rule. Teams should be small enough that 2 pizzas can feed them. It's kind of vague. Maybe they're big to eat pizzas, they're not very hungry people, but. And the developers should be responsible for their code. They need to carry a pager effectively, or at least be able to fix problems in production. The old way, developers build something, throw it over the fence, and then move on to the next product or project, and then the support team ends up being responsible. This is the whole thing about empowering developers. They are responsible for their code through the whole life cycle of the code itself.
What's Conway's law?
I'm sorry?
Conway's law.
Oh, did I miss that too? I'm sorry. You know what? Here's what's happening. I'm running out of time, and I want to make sure I cover the really cool stuff at the end. Conway's law is the law that says that the architecture of whatever you're building, it doesn't even have to be software, but the architecture will follow the organization of your company. So if you've got this big monolithic company with big organizations, divisions, and Actually, what it does follow is more the communication patterns of your company. And so that's Conway's law, and it's been around for a long time.
Is that like Professor Conway at Caltech?
I believe so, yeah, but it's been around for a long
So
time.
what he's referring is actually your technical architecture, whether hardware, software, or embedded software, should be mapped to your business architecture.
Well, so
Yeah.
the inverse of this is you should decide how you want your architecture to look, and then build your company to map that or mirror that, basically. So that's the inversion of Conway's law. So the next part is, these are, again, a bunch of techniques and kind of patterns and practices that I've been watching over these companies that are adopting microservices that they're actually implementing to great success. So first of all, if you're considering this, don't think you're going to do the old waterfall thing and have all these committees and teams figure out how to do this. It's not going to work. Instead, you need to dive right in, start small and move fast. So as an organization, take some little thing, a little service that you can extract out of some of your other apps or whatever, and build a microservice out of that. Then you have a small team that's responsible for this, and then you can start the process that way. So it's like a bottom-up approach, and once you get that in place, you'll see the benefits and the power of microservices, and then you'll be able to hopefully adopt that across your organization. So what usually happens is you have pundits that start this off, and then it gets moved out through the organization. Another thing very powerful is to leverage external services if possible. So Google has like loads of these things, geoencoding or some of their map stuff, or also translation, anything like that. Get in the habit of using external services like that. They have SLAs, they're very powerful, they're very fast. And instead of writing your own, get in the habit of using external microservices, external services with your applications. And then you'll find that you get in that mindset, because I have no impact over Google. I can't call them up and say, hey, can you add a parameter to this call to this thing? They're not even going to answer the phone. Instead, I have to get into that mindset of being able to take what is given to me. And it sounds a little bit more rigid, but actually it just gives everybody a lot more flexibility. I know there's downsides to that. Another very important thing to do, which gets missed out a lot, is make sure you align the environments in everywhere you're going to be deploying your app, starting with every developer system, starting with QA, testing, staging, production, demo systems, proofs of concept systems, etc. Make sure that you're able to have a guaranteed, consistent environment across each one of these. If you don't, you're just going to get in a lot of trouble. We talked about this earlier. Steward your APIs. That's building your own access libraries. I don't need to get into that anymore. These are probably just, I'm going to skip a couple of these because they're kind of, I just don't have enough time. Eliminate all IT barriers, every one if you can. No service desk tickets. Put your IT behind an API. Be prepared to, at least really consider backward compatibility. If you've got all these services deployed throughout your organization and outside, you have to be very careful that if you EOL, end of life a service, that some other service that's still sitting out there on the network isn't going to break because it's relying on it. So what that means is either you need to keep the old services running forever, or you need to, when you write a new service, make sure it's backward compatible, or you figure out a way to deprovision services. I'm sorry, I'm going to have to take questions at the end, okay? But don't forget. Again, so similarly, complete doesn't mean shipped, it means EOL. What that means is that from a developer's point of view, when I deploy my software, as I said earlier, it's not like I ship it and then I'm done and I move on to something else. I'm responsible for this service for its lifetime until it's no longer in service. Just a slightly different what's that word? I lost the word. Fail fast, recover quickly. I alluded to this earlier. Make sure you introduce failure in your system and learn how to recover from it at all times. Think hard about synchronous versus asynchronous services. Synchronous are maybe a little bit easier to conceptualize, but they introduce a lot of problems when you're trying to scale out to these massive systems. So it's a very important thing to, at the very beginning, identify what needs to be synchronous versus async, and then, design for that. And then ideally minimize synchronicity, because if you don't, if you're relying on call response, you'll find that as you try to scale this thing out massively and having lots of consumers and these services, you're going to get yourself into trouble. Feature flags is a good thing to consider. So basically flags that turn on and turn off functionality of your application or your service in real time in production. And usually, or sometimes it's implemented as fields in a database. And I change that database field and it turns off this function, like the search field just goes away in my application or whatever, the search functionality. Very useful when you're rolling out new features. Very helpful in A/B testing or rolling out to a small subset of users. Okay, this is a really important one. Step away from the infrastructure. Do not write your service so it's reliant on AWS or OpenStack or VMware. Step above it. And first of all, that allows you to move from one of these systems to another if you need be. So it's very common for a company to have in-house on-premise infrastructure. They build their services for that. And then, but soon they realize that for what they're doing, it just makes so much more sense to run it on AWS. But to re-architect that whole thing from, they're directly calling all this stuff in the infrastructure to build it out, for then to move to AWS, it's a huge amount of work. There's all these compatibility problems, impedance, mismatch, all sorts of things. You want to abstract above that. So when you're writing your code, you're writing not to the infrastructure, but to some abstraction layer above that. And that's where we come in. Okay, this is an interesting one too. Kind of a little counterintuitive, but a common trap that people get into is writing these multiple microservices that are supposed to be loosely coupled and isolated, but they actually share a common database schema, right? So suddenly they're not decoupled at all. They're actually very tightly coupled, because if you want to make a change to the schema, it's going to affect every service that relies on it, that depends on it. So it's a lot of cases, it's much better to have your microservice include the database, whatever it is. And that's where you get to do things like run MongoDB here, and run CouchDB here, or whatever, doesn't matter. Neo4j, if you want. You can do things like that, or just have separate schema in Oracle or in MySQL for each microservice. It gives you this separation. Now, the problem is it might cause duplication of data, issues like that. This is an architectural discussion that you'll need to have, and how to, either you're going to have duplication, or you're going to have some dependencies, or another option is to write a third service that's providing that data for you. It's my little data service that I can call from all my other microservices. But I'm not sharing at the schema level. Now I'm breaking it off by microservices, is what we're trying to do here. Okay. This is more about, I'm gonna skip a couple, I apologize. Monitoring from day one. These next 4 slides are really just basic. When you're building out your architecture, make sure you bake in monitoring from the very beginning. Don't leave that until 3 months before you're going to deploy. It has to be from the very first second you write code. Same with security. Don't leave that. It has to be built in to everything you're doing. Scaling as well. It's so common. You see it all the time. Companies build this cool application. They get close to a few months off deployment and say, okay, well, let's scale this thing. And then they have to start building this whole scaling infrastructure, these testing and these harnesses and bashing out this thing. And often what happens is you end up having to re-architect your application to support scalability. Instead of that, start from day one. You build a hello world application. It has a panel and a button and a database. And then from the day one, you scale it up to 10,000 requests a minute or whatever you think is far beyond anything you're going to need. And then make sure it can handle that. And then and then incorporate that into your whole testing plan. So as you're evolving this thing, you know that it always can support 10,000 users a minute or whatever. Do not hold off on that. And so to cover this before fail from day one. I guess we're doing okay. And also automate from day one. Eliminate as much as possible all human intervention. Okay, briefly on this polyglot versus monoglot thing we talked about earlier. Microservices does allow you to use different languages for each microservice if you want. That's kind of one of its benefits. But it kind of comes at a cost, because if as an organization I have Ruby developers and Java developers and Python, it gets very complex to manage the tooling and everything else to sort of at the higher level. Documentation is different. It's hard to move developers from team to team. So there's definitely pros and cons. And you find, so here's kind of what happens in the industry, is that the reason you'll find polyglot usually is for legacy reasons, meaning I acquire a company that's a bunch of Ruby experts and everything, all their code and everything, and I want to retain that. So then I keep that as Ruby while the rest of my shop is Java, and that gives me the polyglot kind of requirement here. But you'll find if you're building a greenfield, a new application that you can choose your whole stack, it's generally recommended to minimize the number of disparate technologies you're using, if you can. Because, you know, these days, anything you can do in Ruby, you can do in Java, and you can do in all these other languages. It's, you know, you can pretty much do it. One of the advantages of Java, or the JVM, is that there's all these other powerful languages that sit on top of it, and they can share the common tools. So Scala and JRuby and Clojure, for example, and Java, you can have all those four, your services written in all those, and you can still retain some of the tooling. So it's, anyway, something to consider. Versioning, it's important you keep this in mind as you're building up your microservices, to figure out how you're going to version each service, and then roll back. And you know how clients, the question came up earlier, does a client choose which service it's, which version of a service it's actually calling or accessing? We talked about empowering developers. As you're building out microservices, make sure you just have the mindset of being willing to take it out and start over again with the service. And what that means is if you built this JavaScript, you know, CouchDB little service, and it's working okay, but the performance is off a bit, you can, you know, be ready just to rewrite the whole thing in Java, and it's much more reachable to do so with these small components. This is more organizational. Identify people in your company that you can lean on to help propagate this. Okay, so here we get into sort of the more interesting part of the talk as far as I'm concerned. As you're looking at microservices, it's really important to have an understanding on what is out there to allow you to build your architecture apps to support that. And you know, everybody here is kind of doing that already, researching what's going on just by coming to meetups like this. There's practices, tools, APIs, components, patterns. I'm going to just briefly dive, as I said earlier, some of the patterns, that could be a whole 1 hour talk, but I want to just briefly dive into a couple that are kind of interesting. Patterns that are useful for microservices deployment. So one of them you might hear is the CircuitBreaker pattern. And like its name implies, it's similar to a circuit breaker. You've got in the electrical world, if I overload a circuit, I've got this circuit breaker that pops open, opens up the circuit and cuts power to whatever was drawing too much power at the time. And what that does is it saves me from burning down my house because I plugged in this weird toaster or whatever. So the same thing applies, or the same kind of concept applies in software. If a component or a service is drawing too much power, so to speak, I can then kick the circuit breaker and cause requests to that to no longer go through. So let's say a service is taking too long to respond. If I can detect that, then any subsequent consumers of that service, I intercept those calls and say, well, no, it's down, so just return immediately instead of 3-minute timeout or whatever it is that this service is exhibiting, which is very destructive to your system, as you can imagine, taking 3 minutes to make a call, as opposed to a few milliseconds to say, well, it's broken. So that's kind of how it works. The circuit breaker is one way to implement it is as a state machine that's wrapping calls to other microservices. And as I said, the whole point is that you fail immediately if there's a problem with an external or an internal service. So there's the consumer that's calling that service, but this circuit breaker sits in the middle. And I don't know, I may be getting into too much detail. You define a threshold, you figure out what it means for your service to fail. Maybe it could be the number of failures or the frequency of failure, all sorts of metrics. And then if that threshold is surpassed, maybe it takes, 3 seconds to respond when you're calling the service, then pop the circuit breaker open, and all calls to that service will then get cut off before it even gets to the service. So if the service is being overloaded by calls, this will at least relieve it all this extra load, and then the client, the consumer, gets informed immediately that there's a problem with it. So it's basically a state machine. I don't know if I'm getting into too much detail here, but there's 3 states. There's closed, which is normal operation, so all calls go through the circuit breaker to the service itself. But if there's a problem, then it kicks it to open, so it cuts off all calls. And then after a certain amount of time, it will make it into this half-open state, so that it will, meaning that the next call comes through, it will try to make it, and if it doesn't make it, it'll reset it to just open or fail. But if it does make it through, it goes back to the working functional state. So basically a state machine, you need to inject it between the caller and the callee, between the consumer and the service itself. So it's a common pattern, and you'll see there's a lot of libraries or tools available that are starting to evolve to deal with this. Circuit breaker is a very severe thing, so if the circuit breaker kicks, it means there's a serious problem with your app. Report it, make sure that ops is aware of it and the developers. Okay, this is an important one as well. Bulkhead, you might have heard, so bulkhead in a ship, you have these multiple sections of the ship that if one of them fails and fills with water, it's not going to sink your whole ship. If you have this big hull in your ship and gets breached and the whole thing fills with water, the ship's going to sink. But if you cut it up into individual components, or bulkheads, then if one of them gets breached, hopefully the rest of the ship will remain afloat. And that's the idea with the bulkhead pattern and what we're talking about here. So you're partitioning your systems so that a failure in one will not cause problems with the rest of your system. You're isolating the failure. So if you've got a consumer that needs to consume this, let's say a geo-encoding service that you have running out there, and it's a very critical service. It's for payment orders. It's for your ordering system. It needs to do this geo-encoding to figure out where your address is or whatever. But then you've got these other little non-essential applications calling it as well. If one of these non-essential apps goes out of control and calls my geo-encoding service a gazillion times, it will crash my mission-critical service or app. So what you want to do is make sure that you have multiple instances of these geo-encoding services, one for the critical, or multiple for multiple critical, and then multiple for, or the rest for the non-critical. So you guarantee your service level agreement. However, you should be aware that bulkhead does impact your capacity. Meaning that if you're separating up if you're partitioning up your system, each partition will have its maximum capacity. If you were to just have them all together as one big system, you would have all the capacity available at all times. Here you're by definition cutting it up. So some examples of bulkheading, and it can be very coarse or very fine. You could have multiple server farms where each server farm is, this one here is responsible for the critical stuff, and this one's for less critical, for example. And then you can bring it right down to CPU binding, so meaning that one CPU is responsible for this class of requests, and then this one here is responsible, or this group of CPUs is responsible for these less important requests. Thread pools is another example. There's so many of these. Or having multiple, as I said, geo-encoding, have multiple services available, maybe pools of these things, so that if one fails, it's not going to affect the others. And then this is where it gets more interesting for me. VMs and containerization is a perfect tool or perfect technique to provide this bulkheading, because you then can have dozens of containers running on your system. Each one of them is responsible for the same service, but they are isolated as well. Containerization enables that really well. So each individual service is actually isolated, and if it fails, it will not affect the rest of the system. And VMs obviously is the same kind of thing with partitioning your hardware. Finally, platform as a service. almost by definition, gives you for free this bulkheading in many different ways. So most PaaSes today will use containerization, so it will deploy multiple instances of service just out of the box. Another very important pattern or technique practice is to make sure that you incorporate timeouts all over the place for any calls to services. So if you make a call to a service, don't assume it'll return at some reasonable time, a few hundred milliseconds. A lot of code is written just without specifying timeouts. In other words, it'll go forever before, it'll basically just hang forever if it makes a call and it fails. Make sure that all code is written so that it expects a timeout, or that it specifies a timeout in a reasonable amount of time and it knows how to handle it. And this is because, as I said earlier, microservices, you're taking your application and distributing it across your network. And as you know, the 7 fallacies of network computing came out of Sun, or I think it was Gosling or Jim Walter or someone. He defined these fallacies. One of them is networks are always and always will be unreliable. So if you're in the same memory space, you don't often specify a timeout when you make a call from one object to another. Same space, you don't usually need to. But with anything that's going over the network, make sure you specify a timeout. And so any integration point, meaning between this service and that service, or basically anything that's an integration point, you want to specify these timeouts. It avoids cascading these failures. So if I don't specify a timeout, it just goes forever. If it hangs, then that failure is going to propagate up my system. Everybody that calls that's going to hang, and eventually my whole system just grinds to a halt. Whereas if I've got timeouts everywhere, it will fail earlier than later, which is the point. It's isolating faults. You don't want to, related to this, you don't want to make all these immediate retries every time you make a call. If it fails, don't keep retrying it. Give it some time if you're going to do that. And then importantly, be aware of libraries and APIs that are used to these APIs I talked about earlier, where you're wrapping the calls to your microservice. Make sure they're correctly timing out and it's not hanging forever. And we talked about fail fast. And good, so what I'd like to do now, I'm going to skip a little far ahead to PaaS, which is, been a focus of what I've been working on for the last 2 years, and it's a very important technology to be aware of. First of all, how many people here are familiar enough with PaaS that if you were trapped in an elevator, you could, by the time you got to the 7th floor, you could describe what platform as a service is? Just curious. Okay, yeah, that's usually what I see. So it's getting more and more common. A couple years ago, it would be absolutely nobody. I expect in a couple years, it's going to be pretty much everybody. So what platform as a service does, it basically provides an abstraction layer above the infrastructure. It provides a platform for your software team to deploy and deliver applications. It takes care of a lot of the plumbing you would otherwise have to deal with. So I'm just going to list some of the things here that it takes care of. Managing your clusters of systems, of VMs or whatever, doesn't matter what it is, but managing the clusters of them so you don't have to, as a developer, worry about the nitty-gritty details of provisioning VMs and getting them up there. Dealing with failover. So if an app instance or a service instance fails or crashes, it can automatically roll over to another instance. Automatically, you don't have to do anything, no extra code on your part to deal with it. Routing and load balancing between all of these services and service instances. Again, it takes care of it for you. All the automation and deployment. So as I said earlier, you want to be able to scale from day one. Make sure your app can support thousands of requests a minute if that's where you're going to be going in the future. And the PaaS will do that for you. So you can deploy this little Hello World application and then from the very day one, use the PaaS and say, well, I want to scale it up to 1,000 instances and see how it responds. Design your testing around that. As I said earlier, polyglot or monoglot, that is multiple languages, is a consideration you need to think about. But if you want it, any PaaS will give you things like Java, Perl, Ruby, JavaScript, PHP. All these languages are just there out of the box. Monitoring and logging, it's huge. So it's very important to maintain visibility of your services, how they're performing, how they're failing, over time, how the calls to these services correlate to what's happening in your business. right? I'm getting 1 million or 1,000 calls here a day, and then I'm selling 500 widgets here. Making sure that I watch these as they change, maybe, anyway, just watching how your business gets affected by the actual underlying performance of your system. Very important to track. So, monitoring and logging is a big part of this, and a PaaS will give you this out of the box. So when I deploy my little microservice here, or an application, monitoring is wired in, logging is wired in. Logging is a challenge, right? In the old days, it was really easy. I would have one application running, and I could use, awk and grep and Perl and all that stuff to watch my log files. But nowadays, you have hundreds of services being deployed and moving around your network and starting and stopping. How do I make sure I capture the logs from every one of these in a centralized place? So there's a lot of work you have to do to make sure that works. But with PaaS, it does it all for you. It wires the logging system for you, allows you to aggregate them in a single place and either deal with it yourself or direct it to Loggly or Splunk or Graylog or Graylog 2 or some other system. PaaS enforces consistent environments across all aspects of your system. Development, QA, all that stuff. So the environment will be maybe not 100%, but very close to 100% consistent. And self-service. So one of the promises of the cloud, there's several promises of the cloud, self-service, on-demand, scalable, monitoring, all these things that the cloud enables. The self-service part is provided by a PaaS, so that the users of the PaaS simply make an API call or click something on a UI or run a shell script to scale my app up to 200 instances and click a button. I don't have to submit a service desk ticket or get anybody else involved. I just click a button or call an API and it's done. Very important feature of the platform as a service. I talked about earlier the immutable service patterns. That's the ability to deploy multiple service instances and retain them so that if you need to roll back, you can. The PaaS will take care of that for you. That is, including rolling back and rolling forward. And all of the versioning issues you need to concern yourself with are all handled by the PaaS. And if you want to upgrade your service, it will do so. If you do want to do it in such a way that you're replacing it, you can do so in real time with zero downtime. And it handles that. I can get into it if you want. Upgrades and rollbacks. So that's actually, I think I covered it, yeah. 2 minutes left for the presentation part. And I do again apologize for cutting off questions. But now is a good time, so yeah. So I think, yeah, go ahead.
Implicitly, you didn't really mention the word Scrum or Agile, but it seems that PaaS is a little bit difficult to do without Scrum or Agile approaches.
So the question is PaaS compatible with Scrum? And absolutely, it's actually, in my viewpoint, it enables it even more. So you have these small teams deploying their small components to the PaaS. And the PaaS could be running on a laptop or running in the data center, but it's the exact same environment for everybody. So there's actually, in my view, it actually streamlines the whole Agile process. But I'd be curious how you feel it might not.
No, I'm just saying I don't know how you do this without using Scrum or Agile or one of
Oh, right,
those
you need
techniques.
Scrum, yeah.
It's not really practical otherwise.
Right, so it's a very powerful, yes, exactly. The team that's building microservices is a very common way for them to use the Scrum, the Agile
I mean,
methodology.
even test-driven development is implied in what you're talking
Right.
about here.
It helps. It's not absolutely required, but it absolutely helps, yeah. TDD and Agile, for sure, so yes. Yes.
Some of the patterns you mentioned, for example, timeouts, seem like maybe they're at the infrastructure level. The individual process doesn't have to worry about that. There's some layer between them that is in place already, or the PaaS applies it to get timeouts. Does everyone have to code their own? How does that?
So where do timeouts fit in this whole thing?
Well, that's just one, but all of those have a kind of an infrastructure quality. That is, they don't exist within any particular container or process.
Right. Okay, yeah, so all these patterns, like timeouts or maybe CircuitBreaker, ideally, so that's a really good question, because ideally what you want is your platform to deliver this stuff for you. So I use CircuitBreaker as an example. I want to use CircuitBreaker, I want to have that between my client and my server, back here. This whole thing, I want to inject this thing in the middle between my consumer and my service itself. So wouldn't it be nice if the PaaS itself just handed this to me, gave it to me, Now,
Well, enforced it also.
and enforce it, exactly. Well, there's times when you might not need to enforce it, right? So, because it does introduce some overhead, there's, you know, an extra method call or whatever, so. But that's a design decision, or a requirements decision. But wouldn't it be nice if the PaaS gave it to you and it was just there? And as I said, the tooling is evolving. The gentleman that left it asked about this. The tooling is evolving, and it's kind of a little bit behind microservices to support things like that. And Netflix has produced all these really powerful libraries, like Eureka, for example, which helps with this. And it is being rolled into Cloud Foundry right now, the Cloud Foundry PaaS, so that you will get CircuitBreaker for free. But right now you can actually do it with Staccato, for example, or Cloud Foundry. But it requires, you know, a little bit of work to make it happen because it wasn't designed out of the box for that. Great question. So here's this trade-off between customizability and control, or just doing however the PaaS, whatever the PaaS requires. And so this is such a common thing that almost everybody runs into, is the PaaS will do right away 80% of what I need to do, but I've got these usually legacy things I need to do that it doesn't do very well. And then I need to invest time to fix the PaaS to make it do what I'm doing, or fix my app so it isn't doing it anymore, right?
Sometimes it's also for compliance. You want to track low-level details and in the infrastructure.
Right. So yeah. So that's a really good point too. So how about compliance when you need to have low-level audits of everything, every network, firewall rule, everything that's going on in your system? If the PaaS steps you away from that, how do you deal with that? So there are a lot of work being done with exactly this. I was involved with the project a year ago, integrating Staccato PaaS with Citrix Cloud Platform Business Manager, which takes care of all the orchestration and auditing and monitoring and all that stuff. So we tied Cloud Foundry, Staccato, into that. So all these things can be directly accessible. But to your first point, there is a trade-off between what the PaaS provides and what you might need to do with your app. And that is exactly that's kind of where my job is going into a company and saying, well, you're doing this, how can we make this work in the PaaS? One example might be, my application is talking, it's not necessarily talking HTTP, it might be talking some other protocol. Name anything, SMTP, whatever. A lot of the PaaSes today force you to use HTTP between applications or services. Or maybe it's even using UDP or something. How can I deploy my UDP app to the PaaS? And so these are the things that people have run up against. And what we did about, 3 years ago, we recognized that problem, and now Staccato supports UDP, TCP, doesn't matter, binary data, it doesn't matter. But as I say, it's evolving, really crazily evolving. So all these things that you're identifying there, enough companies hit against it, it gets solved. And then, and then you do it. Great questions, I really appreciate it.